Good evening to all of you.
Good evening, sir.
Okay, good evening to all. Okay, within 2 minutes we'll start. Okay, let's wait 2 more minutes. Some more people may be joining. And I request all of you, if you have any queries, any doubts, please send it to the coordinator. Okay, through WhatsApp, we can send it. Otherwise, in chat box, I think it is not possible to send all the questions, especially mathematics questions, etc. It is very difficult to type in the chat box, and I am also unable to read it from the chat box. Okay, so better you can send it through WhatsApp to the coordinator of this program. You can consult your school principal or your teacher. They may give the WhatsApp number.
Okay, sir.
Is it clear? Okay, children. Good evening to all of you. Hope that my audio voice is coming to you. Okay, so shall we start? Okay. So the next application of this chapter, that is the maxima and minima. Okay, maxima and minima. It is also just like the increasing and decreasing function, almost the same concept only. Okay. So I already told you, if you have any questions or any queries or any doubts, please send it to the course coordinator, okay, through WhatsApp, so that I can address those problems in the next class. Okay. If you are sending through the chat box, it is unable to read sometimes. Clear? Okay. So maxima and minima. Another important application of this, another important topic of this chapter actually. Definitely you may get one case study question also from this area. Okay. One case study question for 4 marks, otherwise one 5 marks question. So it is just like the increasing and decreasing function concept actually, almost same only. Okay. So let me show you a graph of a function. Okay. See this presentation. So you see this graph. Okay. So what you can observe, this function has a lot of turning points. No? Somewhere it attains some maximum, and somewhere it attains some minimum, Okay, some turning points you can see. Okay, at the point 1 you see, at the point 1 what you can observe, the function attains some maximum at that point, you know? And after some time at the point B, you can see that the function attains a minimum at that point. Okay, again, if you move forward at the point 6, again this function attains a maximum. Okay, and again if we move forward at the point D, again we can see that the function attains a minimum. Okay, and these points, these turning points, at the point 1 you can see a turning point, at the point B, that means actually 4 actually. Okay, the value is 4 at the point x equal 4, again you can see a turning point in the graph of the function. At the point 6 also you can see a turning. At the point x equals 6 also you can point the turning. And at the point 9, the point is D actually, the value is 9. At the point 9 also you can see a turning in the graph. Okay, so these turning points actually known as the critical points actually, just like the increasing decreasing case also. Okay, where the function has a turning. Okay, some turning is happening at these points, and those points are known as critical points actually. Okay, at that point the derivative will be zero. Derivative will be zero if it is differentiable function, and sometimes the point can be a non-differentiability also. Okay, if sometimes there may be a sharp edge. I will show you another. Okay, sometimes the graph may be like this. Okay, here also you can see that at the point around 3. Okay, the function has a turning point. Okay, now after at the point 6, x equal to 6, again the function has a turning. You know? And at the point 8, again the function has a turning. But remember, at the point 8, the point is at that point 8, x equal to 8, the function is not a differentiable. Okay, it's a sharp edge actually. Anyway, that is also a turning point. Yeah, that is also a critical point actually. We say critical point. Okay, so actually maxima is the plural of maximum. Okay, so many you can observe that at different points the function attains a maximum or a minimum. Okay, so this point x equal to 3, actually this point x equal to 3, the function attains a maximum in that neighborhood of 2. Okay, just nearby 2 the function attains a maximum, but it is not the maximum of the function actually. Okay, the function attains again at the point 8 also you can see the function attains a maximum. Okay, and that is more than the value at the point 3. So this point at the point 3, yeah, the point A, the function attains a local maximum. We say the word local maximum means in that locality only this function attains a maximum. Okay, in that locality. Okay, means just nearby 3. And you can see that at the point 6, again you can see that is a point of local minimum. We say the x equal to 6 is the point of local minimum. Okay, local minimum stands for in that locality, in that particular locality, means just nearby 6 the function attains a minimum. Okay, function attains a minimum, so that is a point of local minimum. And x is a point of local minimum, and correspondingly the function value you can see on the y-axis. Okay, the function value correspondingly when x equal to 6, what is the corresponding value of the function here in the graph? You can see the function value is 2. Okay, so the value of the function at x equal to 6, yeah, f of 6 actually, f of 6, that is called the local minimum value of the function. Okay, And again, at x equal 8 also, that is a point of non-differentiability. Again, that's the critical point. And very clearly from the graph, you can observe that at x equal to 8, the function attains a maximum, a local maximum. Okay. So it is also a point of local maximum. Remember, that is the point of non-differentiability also. So a critical point can be a point where the function is not differentiable or it is differentiable also. Okay. Means derivative is equal to 0. If it is differentiable, means the derivative will be equal to 0. Okay. So 8 is a point of local maximum very clearly. Okay. So that's the meaning of local maximum or local minimum. Okay. There may be so many turning points. So these points are, we say, local maximum, yeah, local minimum. Now, after understanding the concept of local maximum, yeah, local minimum, now we are going to apply calculus. How can we identify, yeah, how can we confirm whether a point is a point of local maximum or a point of local minimum? How calculus can be applied here? Okay. So for problem solving, we need a technique. Okay. We need a technique to identify, to find out the point of local maximum and local minimum also. Okay. So that we are going to discuss here. For that, there are two methods actually. Okay. There are two methods. And the first one is known as first derivative test. All of you might have studied actually. Okay. Just I am recalling, repeating only. First derivative test. And another one is second derivative test. Second derivative test. So what is mean by first derivative test? First, I will explain what is first derivative test with this graph only. With the example of this graph. Okay. So very, very clearly, at the point 3, the function attains a local at the point 3, around this point actually, okay. In between middle of 2 and 4 means 3 only. So at the point 3, this function attains a local maximum. Very clearly from the graph, you can observe that. Now, how calculus can be applied here? How calculus can be applied here? So what you can observe very clearly, just the left side of that point, just left side of that particular critical point, that is 3 actually, just left side of 3, what we can see, the function, the graph, from the graph, you can see that the function is of increasing nature. The function is strictly increasing nature. So increasing function means what? We know when we say that a function is increasing, strictly increasing, derivative must be positive. Clear? So very clearly from the graph, you can see that left side of that critical point, the derivative of the function is positive. And right side of that point, right side, just if you cross that point, right side of this point, the derivative is negative because the function is decreasing nature. Decreasing means derivative is negative. Okay. So if this is the condition, okay, if there is a function and suppose there is a critical point, okay, some critical point, now we have to identify how to get critical point actually. Critical point means f dash x equal to 0. Okay, f dash x equal to 0. Otherwise, f dash x does not exist. Okay, f dash x does not exist means not differentiable also can be a critical point. Okay. So very clearly, after getting the critical point, once you identify the critical point, how to tell, yeah, how to decide, how to get that it is a point of local maximum, local maxima. So how to get it? From the graph, it is clear now. From the left side of that point, function must be increasing, and right side of that point, function must be decreasing. Okay, that means left side of that point, f dash x must be positive, and right side of that point, f dash x must be negative. So if f dash x changes the sign from positive to negative, positive to negative, that is a point of local maximum, point of local maxima. If there are so many points, okay, point of local maxima. So this is the meaning of the first derivative test. Okay. Now, similarly, if it is a local minima, let us come to the point 6 actually. Very clearly, you can observe from the graph that 6 is a point of local minimum, local minima. Now what happens to the left side of 6? To the left side of 6, very clearly the function is of decreasing nature. Function is decreasing. Then after 6, right side of 6, the function is increasing nature. That means left side of 6, derivative must be negative, and the right side of 6, derivative must be positive. Okay. So at a critical point, to the left side of that, just left side of that critical point, suppose the derivative is negative, and just right side of that critical point, derivative is positive. That means f dash x changes its sign from negative to positive, negative to positive. That confirm that, yeah, that indicates that that is a point of local minimum, yeah, local minima. Okay, minimum. Minima is the plural of minimum actually. Clear? So this method, this test is known as the first derivative test. Okay. Clearly at the point 8, what you can see? At the point 8, left side of 8, the function is increasing nature. And the right side of that critical point, the function is of decreasing nature. So very clearly, that is a point of local maxima, local maximum. Okay. So this method, this test is known as the first derivative test. Clear? First derivative test. So when a function is given, so how to get the local maximum value, yeah, local minimum value? For that, what we have to do? First, we have to find the critical point. First, we have to identify the critical point. Critical point means what? Either derivative equal to 0 or the function is non-differentiable. Those points are known as critical point. Most of the cases, we will get only differentiable functions. Okay, so first we find the derivative. When we find the value where derivative is equal to 0, where there is a turning means definitely there will be a point at which the derivative must be derivative must be 0. Okay. So just you remember, okay, for local maximum, the graph may be in this way, in this nature. Okay, the shape of the graph. And this point will be the point of local minimum. This point, suppose I take a C1. C1 will be the point of local maximum. Sorry, local maxima, a local maximum. Okay. And at this point C1, definitely the derivative must be 0. At that point, derivative must be 0. If it is differentiable function, derivative must be 0. And left side of that point, what happens? The derivative must be positive. Derivative must be positive. Function is increasing nature. And just if you close that point, the function is decreasing nature. That means on the right side of that critical point, derivative is negative. Derivative is negative. That means f dash x changes from positive to negative. That point is a point of local maxima, a local maximum. Similarly, suppose this is the case, okay, in this way, the graph of the function may be in this shape. That means, suppose this is the turning point here, critical point. Okay, suppose I take some C2, that point. So very clearly, to the left side of that point, the function is decreasing nature. That means f dash x is less than 0. And to the right side of that point, function is of increasing nature. That means derivative must be positive. You know? So derivative, left side it is negative, right side it is positive. That means the point C2 is a point of local minimum, a local minima. Okay. And at that particular point C2, at this point, the derivative must be 0 also, if it is a differentiable function. Okay. So this is the way, we have to remember to identify a point is a point of local maxima, a local minimum. Okay, clear? And sometimes left side of that critical point, right side of that critical point, the derivative sign may not be changing. Okay, there are some functions Left side is also positive. Right side is also derivative is positive. Okay. In such a case, what we say, that point is not a point of local maxima or local minima if there is no change in the sign of derivative, okay, left side and right side, then in that case, that is not a point of local maxima or local minima. Such a point is known as the point of inflection. Okay, point of, sometimes you can see some graph of a function, okay, it will come up to here and there is a turning actually, and again the next turning will be again in this direction only, like this. Okay, so actually some turning will happen here at this point. So at that point, you will get, if this point is some c, at this point the derivative will be zero only. Okay, derivative will be zero only at that point. But to the left side of c, the function is increasing nature, and right side of c also the function is of increasing nature only. So this is not a point of maximum, okay, local maximum. So this is a point which is known as point of inflection. Point of inflection. Okay. So this test, this method is known as the first derivative test. So you just understand the technique only, the method only. Okay. There is no need of by hearting the statement of the first derivative test, etc. for examination purpose of you. Just understand the meaning of the first derivative test. Okay. Okay, in this graph, you can find so many turning in the graph. No? So x equal 1, very clearly, x equal 1 means it is a point of local maximum. Okay. And x equal to 4 is a point of local minimum. X equal to 6 is a point of local maximum. And x equal to 9 is a point of local minimum again. Graphically, very easily we can see. So algebraically, the method I have explained. Okay, first derivative test. What is meant by first derivative test? Now, there is one more test actually, one more method actually. That is known as the second derivative test. Okay, sometimes we will be applying second derivative test. That will be more easy than the first derivative test. Both method you must be knowing, you must know. Okay. In second derivative test, what we have to do? First, we identify the critical point. Okay. How to get the critical point means? How to get the critical point? Find the derivative of the function. And to get the critical point, you put f dash x equal to 0. Then after solving this equation, you will get some critical point. So let x equal to c be a critical point, some critical point. Okay. The first step is same only. Critical point we have to find out. Differentiable means you will get some critical point. And if there is some point of non-differentiability, that also should be considered. Okay, anyway, c is a critical point. If it is differentiable means f dash x equal to 0, then that will give some value x equal to c, say. Okay, then what we have to do? In first derivative test, I told you, left side of c, right side of c, we have to check the sign of the derivative. Okay, that is known as first derivative test. In second derivative test, what we have to do? We will just evaluate the second derivative at the point c. Remember, the function also must be a twice differentiable function. Okay, at that point c, the function must be twice differentiable. Okay, so we will find the second derivative and put the value of c for x. Okay, then you may get some value for f dash c. You just see the sign actually. Just observe the sign. If second derivative is positive at the point c, then it indicates that c is a point of local minima. Okay, point of local minima. Second derivative greater than 0 means the point is a point of local minima. And also, second derivative is negative means that point is a point of local maxima. Okay. Second derivative positive means point of minima. Second derivative is negative, means point is a point of local maxima. So this is the second derivative test. So two tests we are using to identify the local maximum or local minimum value of a function. Okay. And sometimes in second derivative test, after getting the second derivative, and if you put x equal to c, the critical point, the second derivative also can be 0. Okay, that's also possible. Always it may not be second derivative positive or negative. Sometimes the second derivative value also can be 0. Then what to do? Then we cannot say anything using the second derivative test. Okay, second derivative test fails. In this case, we say like that. The second derivative test fails. Okay, we are unable to give anything if second derivative is also 0. At that time, we will go back to the first derivative test. Okay, left side of C, right side of C, we will see the sign f dash x positive or negative like that. And we will identify it is a point of local maxima, yeah, local minimum. Okay, if it is not changing the sign, if f dash x does not change as a sign, then we say that it is a point of inflection. So two tests are the first derivative test and second derivative test. Clear? Now we are going to do some problems. Okay, based on this first derivative test and second derivative test. You can apply any test if there is no nothing is specified in that particular in the question actually. Okay, you can apply as per your convenient first derivative, yeah, second derivative test. But you must be knowing both methods. Okay. If any doubt in this regard, if any doubt is there, you can put in the chat box. Okay. Okay. So let us take this question. Okay. Definitely from this area, maxima and minima, some question will be asked in case study also, yeah, sometimes directly also. Okay, so this can be asked as a case study also. A tank with rectangular base and rectangular sides open at the top is to be constructed so that its depth is 2 meter and volume is 8 meter cube. If the building of the tank cost 70 rupees per square meter for the base and 45 rupees per square meter for the sides, what is the cost of least expensive tank? What is the cost of the least expensive tank? Okay, this kind of problems we have to solve using the first derivative test, yeah, second derivative test. Okay, we have to find the maximum value, yeah, minimum value, this kind of problems. You might have done this kind of problems actually already. So what to do? A tank with the rectangular base and rectangular sides. Okay. So roughly, like this. Okay. A tank with rectangular base and rectangular sides. Okay. So the depth is 2 meter. The depth of the tank is 2 meter. That is given. And volume is 8 meter cube. Okay. Volume is 8 meter cube. Open at the top. The tank is open at the top. So that is to be constructed. Okay. The volume is 8 meter cube. The volume is also given. And building of the tank cost 70 rupees per square meter for the base. For the base, the cost is 70 rupees per square meter and 45 rupees per square meter for the sides. So that's the given information. Okay. So in case study, it may be asked one by one. Okay. What is the relation between the length and the breadth of the tank like that? So for first question maybe. Okay. Then express the volume in terms of X only, in terms of Y only. Okay. And what is the what are the dimensions when the volume is maximum? In that way, the question will be asked actually, one by one. Okay. So how to start this question? So let us take the length of the rectangular tank as x meter, and the breadth of the tank as y meter. Okay. And the depth, the height is given actually 2 meter. That is given. So let x be the length and y be the breadth of the rectangular tank. That means what is the volume? So volume of the tank is equal to x into y into 2. No? X into y into 2. Okay. So volume is given as 8. That means you will get x into y into 2. Yeah, 2 into xy. That's equal to 8. 2 into x into y equal to 8. So from here, you will get x into y is equal to 4. Okay. X into y is equal to 4. So that is the relation between length and breadth of the rectangle. Sometimes the question may be, the first part may be, find the relation between length and breadth. So the answer is x into y is equal to 4. Now, the cost, okay, the cost we have to express as a function. The cost. For that, what is given here? The building cost is like this. Okay, 70 rupees per square meter for the base. The construction of the base, the rate is 70 rupees per square meter. So what is the base area actually? The base area is x into y, na? X into y. So that means the cost for making the base, I will take the cost as C, okay? Cost of making the box, let me take it as C actually. So C is equal to, the base area is x into y multiplied by 70. Okay, multiplied by 70. So this is the cost of making the base only, x into y into 70, plus the other expense, base and 45 rupees per square meter for the sides. Okay, 45 rupees per square meter for the 4 sides. So what is the total area of the 4 sides actually? The depth is 2 meter, okay? The depth is 2 meter, length is x and breadth is y. So one wall where the length is x and height is 2 means it will be 2x, okay? Opposite is also 2x. Then other two walls means 2y and 2y. Okay, so 2x plus 2x means 4x, 2y plus 2y means 4y. Okay, so total side wall area means 4x plus 4y. Okay, 4x plus 4y, yeah, 4 into x plus y actually. 2x plus 2x, then 2y plus 2y. That means 4x plus 4y. This is the area of the four side walls. Okay, and the cost of making the side wall is given as 45 rupees 45 rupees per square meter. That means multiplied by 40. Sorry, 45. The rate is 45. Okay. So cost of making the tank, so we have expressed in this way. Okay. So this can be modified further. X into y is actually 4 actually. No? X into y is equal to 4. So 4 into 70. Yeah, 280. 4 into 70 plus 4 into 45. That means 180 into x plus y. Again, we can modify it as 280 plus 180 into x plus y. Okay. Now you can see the cost function, but there are two variables, x and y. Okay. So we have to express in one of the variable actually. We have to express it in one of the variable. For that, we have a relation x into y is equal to 4. So either we can change y equal to 4 by x, or we can write x equal to 4 by y. So this is equal to, sometimes in the question itself, it may be asked to express the cost in terms of the x, yeah, in terms of y. So here in any variable you can convert, okay? So 180 into x plus y. What is y? 4 by x. Okay. Now this is a function in totally in x. Clear? This is a function in x actually. Some function in x. So we have to find the minimum value of this function. What is the minimum value of this function? Yeah. At what point here? What is the value of x for which this function attains its minimum value? For that, we will apply the any of the test actually. Okay. So let us find dc by dx. First step is always find the first derivative. dc by dx, first derivative. So that is equal to 828 is a constant, so derivative is 0, and 180 into derivative of x means that is 1 minus derivative of 4 by x means minus 4 by x square. Okay. Derivative of 1 by x is minus 1 by x square. So 180 into 1 minus 4 by x square. This is our dc by dx, yeah, first derivative. Okay. Now find the critical point. Okay. We have to find the critical point. Critical point means where the derivative is 0. Okay. Where the function attains a maximum, yeah, minimum. That is called the critical point. So let us equate dc by dx equals 0. So dc by dx equals 0 means this expression 180 into 180 is a constant, so there is no need of writing. So 1 minus 4 by x square must be 0. 1 minus 4 by x square must be 0. After solving, you will get x square equal to 4. X square equal to 4 implies x equal to 2. X is the side actually, length or breadth, so it cannot be negative. So we'll take x equal to 2. Okay. So this is the critical point. Critical point means what? The point where the function attains either maximum, yeah, minimum. So, but we don't know whether at the point x equal to it is maximum or minimum, we don't know. But at the point 2, either the function may be maximum or minimum. So to confirm it, again we have to apply either the second derivative test or first derivative test. But better to apply the second derivative test, okay? Because easily we can find the second derivative. So d square c by dx square. What is the second derivative? First derivative is 180 into 1 minus 4 by x square. So again, if you differentiate 180 into derivative of 1 is 0 only, 0 minus derivative of 4 by x square. So minus 4 into minus 2 by x cube. Derivative of 1 by x square is minus 2 by x cube. Okay. So that means this is equal to 180 into minus means positive plus 8 by x cube. 180 into 8 by x cube. So this is the second derivative. You know? Now very clearly here itself we can see that x means always the length. No? So it cannot be negative. So x cube is positive only. So everything is positive only. Okay. So always it cannot be, we cannot say directly like this. So actually what we have to do is the critical point is x equal to 2. Okay. The critical point what we have got is x equal to 2. Okay. So when x equal to 2, what is the value of this second derivative? That is the general method generally. Sometimes directly also we will be able to say this value is positive or negative. Otherwise, we have to substitute and see. Okay. So when x equal to 2, what is the value of second derivative means? In that second derivative, you put x equal to 2. So very clearly, this is positive only. We need the exact value of the second derivative. We have to say whether it is positive or negative. Very clearly, it is positive. Okay. From here itself, we can conclude that it is positive only. So second derivative is positive. At the point 2, the second derivative is positive. Second derivative is positive means our second derivative test says that the function attains a minimum. Okay. The function has a minimum at the point, at that particular critical point, x equal to 2. Here the critical point is x equal to 2. So that is our conclusion, okay? That is our conclusion. Therefore, C. The C is our function actually. C is minimum. C is minimum at x equal to 2. Okay? C is minimum at x equal to 2. Then we can find y also. Sometimes we have to find the dimensions of the box. No? So when x equal to 2, easily we can find the value of y because we have already one equation. X and y is equal to 4. X and y is equal to 4. So when x equal to 2, so what is the value of y? Y is also equal to 2. Okay. So the dimensions of the box means the length and breadth both must be 2. Yeah, height is also given actually 2 only. So in fact, ultimately we will get a cube. The tank must be in the shape of a cube actually. Okay. And what is the cost of least expensive tank? That's the question actually. What is the cost of the least expensive tank? So that means we have to find the value of C. So we got X, we got Y. Now we have to find the cost. So that means this is our cost function. Okay. This is our cost function. C is equal to 280 plus 180 into X plus Y. So least expensive tank means the expenditure is, the cost is least when X equal to 2 and Y equal to 2. So put x equal to y is equal to 2. Easily we can calculate it. Okay. 2 plus 2 is 4. So 180 into 4 means 720. 720 plus 280 means I think 1000. So that is the answer. In comment, a square piece of tin of side 18 centimeter is to be made into a box without a top by cutting the square from each corner and folding up the flaps to form the box. What should be the side of the square to be cut off so that the volume of the box is the maximum possible? Okay. Some other answer is already given by JNV Karaikal. Very good. 1000 rupees. Okay. And Govind, what is the comment? Science, sir, x square equal 4, then x equal 2 or minus 2. Both are there. Then why we chosen x equal 2 only? Okay, I think I have already explained it. Here x is the side of the box actually. No? X and y are the dimensions of a box. So it cannot be negative. The length breadth cannot be negative. That's why we have taken only the positive value. Okay. Okay. So in the comment box, there was a question. Okay. Actually, that is a textbook problem only. Textbook problem only. It is asked in the term 1 exam also. Okay. If you want, I can give the answer. The problem is a square piece of metal sheet. Has some sheet which is in the shape of a square, and 18 is the 18 meter or centimeter. Okay. Maybe 18 centimeter. Okay. Is to be converted into a box. Okay. We have to make a box using this sheet actually. How to make a sheet, that is also given very clearly in the question. So we have to remove from each corner, we have to remove a square. So we have to remove a square from each corner. Okay. A square piece we have to remove. And the remaining portion, after removing the square piece from each corner, you will get okay, like this we will get some piece. Okay, so we have to fold these flaps and to make it a box, open box actually. So what is the size of the square that is to be cut from each corner? Okay, so that the volume of the box is maximum. Volume of the box is maximum. So draw the figure like this, and suppose we have to cut a square of size x centimeter from each corner. Okay, everything depend upon the square that is to be cut off from each corner. If I tell you to make a box, so different people will make different boxes, no? By cutting different square pieces. Somebody may be cutting 1 centimeter from each corner and folding, they will get a box. And some people may be cutting 2 centimeter from each corner, and again they are also making a box. And some people may be cutting 3 centimeter from each corner. different size box you can make. So which will give the maximum volume? So how calculus can be applied here? It's a very interesting question actually. So after after cutting the square from each corner, we will make a box. So what will be the length of that box after forming the box? The length of the box will be 18 minus 2x. Clear? From each corner, x and x will removed. X will be removed, so remaining will be 18 minus 2x. Similarly, the breadth also will be 18 minus 2x only. Okay? And the height will be x. The size of the square piece that is to be cut off from each corner, that is x. Then the height will be x only. So that means what is the volume? Volume of the box means, let us take it as V, that is equal to length into breadth into height. Length means 18 minus 2x. Breadth is also 18 minus 2x. And height is x. So 18 minus 2x into 18 minus 2x into x. This is the volume of the box actually. Isn't it? Now, this is a function in x. Very clearly, this is some function in x. Now the question is how to maximize this function. Okay, we have a function. So how to maximize it? So the same technique. Either first derivative test or second derivative test we have to apply. Okay. So for that, what is the first step? To get the maximum value or minimum value, what is the first step? We will differentiate. We will differentiate and find the critical point where it can be maximum, where it can be minimum. So the critical point we have to find out. For that, we have to differentiate. So differentiation you can do by your own way. Different methods are there. Okay, you can apply product rule. Otherwise, sometimes you can expand it and make it as a polynomial. That is depend upon you. What is according to your convenience, you have to differentiate. Okay, if you want, you can expand it. I can take 2 outside actually. 18 minus 2x means 2 is common. Okay, and square of 2 means 4 actually. 4x into, in bracket, it will be 9 minus x. 9 minus x the whole square. We can modify it. And that is equal to 4x into, if I expand it, 81 minus 18x plus x square. Okay. And before differentiation, I will take this x inside so that differentiation can be easily carried out. Otherwise also we can do, but in order to avoid the product rule, I will just multiply x inside and make it as polynomial. Now we will differentiate and find the critical point. Okay. Now this is a function in x, just like a polynomial function actually. Okay. So the remaining processes are same only. First we find the derivative dv by dx, that is equal to 4 into, okay, 81 minus 36x plus 3x square. 81x means derivative is 81. And 18x square means derivative is 36x. X cube means derivative is 3x square. Okay. And that can be again modified by taking 3 outside, that is 12 into, if I take 3 outside, 3 into 4, 12 into, in bracket, it will be 27 minus 12x plus x square. You can do this according to your convenience, okay? There is no hard and fast rule that you have to follow the same thing, okay? Ultimately, we have to find the critical point. That is our target, okay? So anyway, this is equal to 12 into, it can be factorized, okay? The polynomial, this is a quadratic polynomial, x square minus 12x plus 27. This can be factorized. How it can be factorized? X minus 9 into x minus 3. Is it correct? The product must be 27. Product must be 27 and sum is minus 12. That means the two numbers are minus 9 and minus 3. Minus 9 into minus 3 is 27. Minus 9 plus minus 3 is minus 12. So very clearly, x minus 9 into x minus 3. Okay, this is our dv by dx. Now what is the next step? Next step, dv by dx equals 0. The critical point we have to find out, okay? Where the function can be maximum or minimum, means dv by dx equal to 0. dv by dx equal to 0. So which implies 12 into x minus 9 into x minus 3 equals 0. 12 into x minus 9 into x minus 3 equals 0 means x minus 9 equal to 0 or x minus 3 equal to 0. So that means we will get two critical point, x equal to 9, x equal to 3. Okay? X equal to 9 or x equal to 3. So we are getting two critical points, 9 and 3. Now, both values cannot be taken actually. Is it possible to cut 9 units, 9 centimeter from each corner? Actually, the rectangular piece of sheet, whatever is given is 18 centimeter only, 18 unit actually, okay? So if I remove 9 from each corner means what happens? Is it possible? Okay, we can cut and remove 9, but after that nothing will be remaining there, no? 4 pieces will go from each corner, so nothing will be there. So how to make the box? So it is not possible actually, okay? So 9 is inadmissible, okay? 9, well, x equal to 9 is not possible actually. So the admissible value is 3 only, okay? X equal to 9 is not admissible, okay? The reason is very clear. 18 minus 2x is the length actually. 18 minus 2x becomes 0 actually. So we cannot make a box with a 0 length. So therefore, x must be 3 only. Okay, so we have confirmed that x equal to 3 is the critical point. That means at this point, V, the volume, may be maximum or minimum. We don't know now also whether it is maximum or minimum. Okay, 3 is a critical point. So 3 is the point where it can be maximum or minimum. So to confirm it, what we will do, we will find the second derivative. Okay, what is the second derivative? Already we have the first derivative is with us. First derivative already ready now. So all the three are same only. Anyone you can take and differentiate. Okay. So let us take this one. dv by dx. 12 into 27 minus 12x plus x square. Again, if you differentiate, what you will get? 12 into 27 is a constant 0. Okay. Then minus 12 plus 2x. 12 into minus 12 plus 2x. 12 into minus 12 plus 2x. Is it correct? 12 into minus 12 plus 2x. So this is our second derivative. Okay. Now what we have to do? We have to substitute the critical point, x equal to 3. okay, in the second derivative and see the sign is positive or negative. So what is the value of the second derivative? What is the value of the second derivative at the point x equal to 3, you know, x equal to 3. So what you will get? 12 into minus 12 plus 2 into 3. 2 into 3 means 6. 12 into, in bracket, minus 12 plus 6. So minus 12 plus 6 means minus 6. Okay. So 12 into minus 6 means anyway negative. You know, positive into negative means negative only. We don't want the exact value also. If you want, you can write exact value. Okay, no problem. Minus 6 into 12 means minus 72. It is negative. So second derivative is negative. Second derivative is negative. That means our critical point 3 is a point of maximum. Okay, point of maximum. That means V is maximum when x equal to 3. Okay. Therefore, the volume V is maximum when x equal to 3. Okay. So that means we have to remove a square piece of side 3 units from each corner. Okay. If it is centimeter means 3 centimeter. Meter means 3 meter. 3 units from each corner. So that the box, the volume of that box will be maximum. Okay. This is a textbook problem actually asked in the recent term 1 exam also. Okay. Sometimes maximum volume also may be asked. Okay. What is the maximum volume? That also we can calculate. So what is the maximum volume? Maximum volume. Again, we will take the formula for V. What is V actually? V. The beginning, what we have written, that can be taken. Yeah, this also. Okay, anyone. V is equal to 4x into 9 minus x whole square. V is equal to 4x into 9 minus x the whole square. V is equal to 4x into 9 minus x the whole square. Clear? So maximum volume means you have to put x equal to 3. So 4 into 3 into 9 minus 3 the whole square. 4 into 3, 12 into 9 minus 3 means 6. 6 square is 36. Okay, so you have to multiply and get the answer. 432 may be the answer, I think. Okay, 12 into 36. So 360 plus 72. That you find out yourself. Okay. So I think, okay. Okay, some comment is there. Please cover HOTS and case-based problems instead of textbook problems. Okay. Actually, this problem, why I have taken, it is asked by some of you in this chat box. Okay. That's why I have taken this problem. I know this problem is already in the textbook and many of you might have solved also. Okay. But some of you have asked in the chat box to solve this one. Okay. That's why I have taken this one. Okay. Okay, let me take another problem. So take this question. AB is a diameter of a circle. AB is a diameter of a circle, and C is any point on the circle. C is any point on the circle. Show that the area of triangle ABC is maximum when it is isosceles. Show that the area of triangle ABC is maximum when it is isosceles. I think the problem is clear to all of you. So there is a circle, and AB is a diameter of the circle. C is any point on the circle. C is any point on the circle. Show that area of triangle ABC is maximum when it is isosceles. So draw the figure. AB is a diameter, okay? AB is a diameter. Let O be the center. Now, let us take the radius as R. Okay? So show that the area of the triangle ABC is maximum when it is isosceles triangle. That is the question. When the area is maximum, we have to show that the triangle must be an isosceles triangle. Okay? And we know that this C is a point on the circle means this angle must be always 90 degree. Okay, angle in a semicircle is 90 degree. So basic geometry. So this triangle ABC is a right angle triangle. Very clearly, this triangle ABC is a right angle triangle. Now the hypotenuse of this triangle is 2R. If the radius is R, the hypotenuse of the triangle is 2R only, 2R. That is fixed, okay? Now the other sides of the triangles, let us take it as some X and Y. We don't know about the other two sides. So other sides of the triangle, let us take it as X and Y. Okay? Now, we have to maximize the area of this triangle. Yeah, show that when the area is maximum, triangle is isosceles. Triangle is isosceles. Isosceles means what we need to prove? X is equal to Y. Okay? X is equal to Y when the area is maximum. Okay. So, what must be, what will be the area of this triangle actually? If I take the dimensions, the two sides as X and Y, and the area will be half into X into Y. Clear? Area of the right angle triangle means half into base into height, half into X into Y. So now what is the next step? We have to differentiate A. You know? But before differentiation, we have to convert this into a function in single variable. Okay, X and Y both are variable here, but we have to convert into either in terms of X or in terms of Y. Okay. For that, what to do? We need some relation between X and Y. We have to find some relation between X and Y. It's very easy. Anybody can say, what is the relation between X and Y? Okay. X square plus Y square equal to 4R square. Pythagoras theorem. The triangle is a right angle triangle. So X square plus Y square is equal to 2R the whole square. 2R means, so 2R the whole square means 4R square. Okay. So it indicates that from here we will get Y square equal to 4 r square minus x square. Y square is equal to 4r square minus x square. So that value we have to apply here. Okay. Now the area in place of area A, I will take the square of area. Okay, I will take square, S square. So S square will be what? 1 by 4 into x square into y square. To avoid the root actually, okay. Otherwise, I have to take y is equal to root of 4 r square minus x square. To avoid that problem, what I have done is, I have taken the square of a, that is s square equal to 1 by 4 x square y square. So s square is equal to 1 by 4 into x square into, what is y square? Y square is equal to 4r square minus x square. You remember, area is a positive function actually. So we have to find the maximum value of a. We have to find the maximum value of a. So in place of that, what we will do? We will find the maximum value of s square. We will find the maximum value of s square. So whenever s square is maximum, at the same point, a also will be maximum. Okay. Whenever a square is maximum, at the same critical point, a also will be maximum only. Okay. Whenever a is maximum, s square is also maximum. So there is no problem in squaring this function actually. Okay. If you square, our differentiation will become more easy. That's why I have taken the square. Otherwise, y will be equal to root of 4r square minus x square. Again, differentiation will be a little bit difficult. Okay. So now this is my function. Okay. This is my function, that is s square. S square is equal to 1 by 4 x square into 4r square minus x square. For the time being, we will put some new name for that. In place of s square, I will put z, some new name. Let z is equal to s square, and that's equal to 1 by 4 into r x square. If I want, I can take inside the bracket, okay? So that easily we can differentiate without any product rule. To avoid the product rule, what we have done, just multiply x square inside the bracket. If you apply the product rule also, doesn't matter. That will not make any problem, okay? So dz by dx. Now I will differentiate this z, means dz by dx. What is dz by dx? 1 by 4 into 4r square is a constant. Remember, r is the radius is a constant. So 4r square is a constant into derivative of x square, means that is 2x. Derivative of x square is 2x minus derivative of x raised to 4, that is 4x cube. 4x cube. So this is our dz by dx. dz by dx. That can be further modified 8r square x minus 4x cube. 8r square x minus 4x cube. Now what is the next step? Find the critical point. Okay. Critical point means we have to find the value of x where dz by dx equal to 0. We have to see where the first derivative is 0. dz by dx equal to 0. So dz by dx equal to 0 implies what? dz by dx equal to 0 implies this expression 1 by 4 into 8 r square x minus 4x cube equal to 0. Okay, 1 by 4 is a constant, so it doesn't matter. Okay, there is no need of writing 1 by 4 actually. Everything depend upon this term only. No? 8r square minus x minus 4x cube must be equal to 0. 8r square x minus 4x cube must be equal to 0. So which implies 4x is a common term for common factor. So 4x into, in bracket, what is remaining? 2r square minus x square equal to 0. Common factor 4x taken outside. Normal simplification. Everybody can do all these calculations, okay? So which implies either the first term x equals 0 or the second term equals 0. But you know, x is the side of the triangle. No? X cannot be 0. Okay. X is the side of the triangle actually. So x cannot be 0. So only possibility is what? The second term must be 0. Okay. Which implies 2r square minus x square must be equal to 0. In bracket, you can write x never 0. X cannot be 0. X is the side of the triangle. So which implies x square equal to 2r square. X square is equal to 2r square. And which implies x is equal to root 2 r. X is equal to root 2 times r. So this is our critical point. Okay. So z is maximum or minimum when x is equal to root 2 r. So this is our critical point. But we don't know whether it is maximum or minimum. So that we have to confirm. So how to confirm it? For that, find the second derivative. Okay. So let us find the second derivative. That is d square z divided by dx square. What is dz by dx? dz by dx, we have already got it here. 1 by 4 into 8r square x minus 4x cube. So again, differentiating, you will get 1 by 4 into 8r square minus 12x square. 1 by 4 into 8r square minus 12x square. 1 by 4 into 8r square minus 12x square. Okay. Now we have to see whether the second derivative is positive or negative. At the critical point, that is root 2r, x equal root 2r is the critical point. Okay. Now at this point, we have to check the second derivative. Second derivative, that is d square z by dx square, is positive or negative. So let us substitute here. So 1 by 4 into 8r square minus 12 into x square. What is x square? 2r square. X equal to 2r. Yeah, x square is equal to 2r square. So what you will get? Is it positive or negative? Is it positive or negative? That is only we record is whether it is positive or negative. Okay, very clearly 24r square. So 8r square minus 24r square means it is negative only. Okay, which is less than 0. So therefore, what is the conclusion? Z. Z means, remember, that is S square. Okay, Z or S square. That is maximum. That is maximum. When x is equal to root 2r. Okay. So what we have got is S square is maximum. Remember, S square, we have differentiated S square actually. Okay. S square is maximum when x equal to root 2r. Okay. So whenever S square is maximum, A is also maximum at the same point only. Therefore, A is maximum when x equal to root 2r. Okay. The area is maximum when x equal to root 2r. Now we have to find the other dimension, means other side of the triangle. Y also we have to find. Okay, x is root 2r. So what is y? For that, we take the relation between x and y. What is the relation between x and y? We know what we have written in the beginning. X square plus y square is equal to 4r square. X square plus y square is equal to 4r square. And x square is equal to 2r square. X is root 2r, yeah, x square is 2r square. So 2r square plus y square is equal to 4r square. So, therefore, what we will get? Therefore, y square. What is y square? Y square equal to 4r square minus 2r square. And that is equal to 2r square. So from here itself, it is clear. X square is 2r square. Y square is also 2r square, means x square equal to y square, yeah, x equal to y. Okay. Otherwise, you can write y exactly. Y is equal to root 2r. Y square equal to 2r square means y is equal to root 2r. That means area is maximum. When area is maximum, x equal to root 2r, y is also equal to root 2r. So what is the indication? X and y are equal. No, that means x and y are equal. Therefore, x equal y. X equal y means the triangle is an isosceles triangle. The triangle must be an isosceles triangle. Okay. I think it is clear now. One comment is the sir once again explain this problem. I don't know which problem actually. Hmm. Okay, children. Some people are asking about case study and hot questions. Okay, so this is the one. This is the question asked in the last year CBSE board examination in case study. So please, all of you, uh, read it and note it down. Suraj's father wants to construct a rectangular garden using a brick wall on one side of the garden and wire fencing for the other three sides, as shown in the figure. He has 200 meters of fencing wire. 200 meters of fencing wire. Based on the above information, answer the following questions. Okay. Surya's father wants to construct a rectangular garden. 1 second. One comment is here. Find the point on the parabola y square equal to x, which is nearest to the point 1,4. Okay. I think this is the question asked in the term 1 examination. Okay. We will explain, okay, after the after this problem, after this case study.
Yeah. Okay.
Okay. So students, I think all of you have noted down this problem. Suraj's father wants to construct a rectangular garden using a brick wall on one side of the garden. Okay, one side he is planning to make a brick wall and wire fencing for the other 3 sides. And he has 200 meters of fencing wire. 200 meters of fencing wire. So this is the given information. So based on the above information, answer the following questions. Okay, x meter denote the length of the side of the garden perpendicular to the brick wall, and y meter denote the length of the side parallel to the brick wall. So determine the relation representing the total length of fencing wire and also write A of x, the area of the garden. So first part is you have to express the relation between x and y and also write the area in terms of x. Okay, A of x stands for the area in terms of x. Then determine the maximum value of the area. Determine the maximum value of the area. So first you have to draw a figure. Okay, a rough sketch of this garden actually, a rectangular garden. So just to draw a rectangle. Okay, I think the problem is clear. Surya's father want to construct a garden. Okay, means wall for his garden. Rectangular garden. One side he want to make a brick wall. Okay, wall using bricks. And the remaining 3 side fencing using some wire. Okay. The length of the garden, which is perpendicular to the brick wall, that is given as x in the question. Okay. The length of the garden, which is perpendicular to the brick wall, that is given as x. And the other is given as y. Okay. Once again, you see the question. X meters denote the length of the side of the garden perpendicular to the brick wall, and y meter denote the length of the side parallel to the brick wall. Determine the relation between representing the total length of fencing wire, and also write A of x. So actually, what is the length of the wire given here? 200 meters. Okay. The total length of the wire which is given is 200 meters actually. So according to the given condition, what is given here? The total length of the fencing wire, that means x plus y plus x, and that is equal to 200. Okay, or we can write it as 2x plus y. 2x plus y is equal to 200. So this is the relation between the length and the breadth of this garden. Okay, 2x plus y is equal to 200. Now we have to find the area of this garden in terms of x, that is given as a of x. So area of the garden. So that is also very clear. Rectangle area, everybody knows, length into breadth, that means x into y only. Okay. Area is x into y. Now we have to express is in terms of x. Okay. We have to express this completely in terms of x only. That means we have to change y. We have to change y. So y is equal to 200 minus 2x. From the first relation, y is equal to 200 minus 2x. So this is our area, yeah, a of x. So that is also ready. Okay. So this portion, up to this portion, I think 2 marks. Okay. The first part, 2 marks actually. Now determine the maximum value of the area. So that is the next part. What is the maximum value of the area of the garden? So for that, we have to apply the our second derivative test. Okay. For that, we need to differentiate it. So once again, if you want, we can modify this into a simpler form so that we can easily differentiate without any product rule. Okay. Let us multiply this x inside. So 200x minus 2x square. We can write it as a expanded form. So this is our area. Now differentiate it as usual, the same procedure. So what is a dash x? I can write a dash x, f dash x like that, okay? dA by dx, yeah, a dash x, and that's equal to, everybody can do it, 200 minus 4x. 200 minus 4x, okay? Now the critical point, we have to find the critical point means we have to see when the derivative is 0. So a dash x equals 0, a dash x equals 0 implies 200 minus 4x equal to 0. Yeah, 200 is equal to 4x. Okay, very easily we will get the critical point. Very easy. So which implies x is equal to 50. Okay, so this is our critical point. X equal to 50 is our critical point. That means the area may be maximum or minimum at this point when x equal to 50. Now we have to confirm whether it is maximum or minimum. For that, we have to write the second derivative. Okay. What is second derivative? A double dash x. A double dash x. A dash x is 200 minus 4x. So a double dash x is very clearly that is minus 4. Okay. A double dash x is derivative of 200 minus 4x, and that's equal to minus 4. So very clearly, directly we are getting the value as negative. Okay, there is no need of any substitution of x value because there is nothing is here actually. Directly we are getting the second derivative is negative, means a must be maximum, you know, or second derivative test say that the function, okay, a of x is maximum. A is maximum. When a is maximum? At the critical point. What is the critical point? 50. Okay. So we got the value of x. Now we need the value of y. So that is very simple. Everybody can calculate very easily. From the relation, 2x plus y is 200. Okay. And x is 50 means 2 into 50, 100. plus y is 200. So very clearly, what is y? So what is y? Is equal to 100. Okay. So this is the second part, answer for the second part. Okay. I think that is the question. Determine the maximum value. Determine the maximum value of a of x. After getting x and y, we have to find the maximum value of the area. So one more thing is remaining. What is the maximum value of a of x? Okay. So what we have got just now is area is maximum when x equal to 50 and y is equal to 100. Okay. Now what is the maximum area? Maximum area is obtained from area formula. Area formula is x and y. No. So directly you can find out very easily. Just multiply 150. So maximum area is how much? 50 into 100. Okay. So I think the time is already more than 8. So it is the time to stop. Okay. So we'll stop here. And I already told you, if you have any queries, any questions, please message it through WhatsApp, and so that we can address tomorrow. Okay. So we'll stop here. Okay.